How to find derivatives of composite function. Now, if you need some prerequisites of composite function, some recaps, see the chapter 3 of this section. And if you don't need it, we can start here, or click the chapter 3, then you can come back over here. Now the chain rule, we have got it. The formal chain rule, the way it is. Given function of x, first thing is we have to be very careful. F of x is this value. G of x is another value. H of x is another value. H of x is a composite function. Is function of the g of x. We can get the information of g of x from here. We have to find h prime of x. So let's just first write what is h of x, h prime of x. All we are doing is following the formula. Is the f prime of the whole g of x times it by the g of x. F prime of the whole g of x times it by just the g of x. That's the formula we are using. And this formula is over here. So we need to figure out what is f prime of g of x. G of x information is there, and what is g prime of the x. So we will use all this piece of information, combine it, that's called the composite function. Start with f of x because we are running for f prime, so start with function of x. Just we are copying this value over here. Done. We can run for f prime of x. So f prime of x is the 2 times the whole value with the new power 2 minus 1. So we are not making it complex. So it's 2 times x minus 3, power of 2 minus 1, power of 1. Done. Now we can figure out what is f prime of g of x. So all we do is replace this x by g of x. We can use this one. Replace this value with the g of x. Replace the x with g of x. So we pick up this piece of information. What we do is just, instead of f prime of x, plug in g of x. I didn't write the g of x, so it's much cleaner. We will plug in the x later. So it's 2 times x minus 3, 2 times g of x minus the 3. Simple. And that's the g of x. Plug in the value. But it's a g of x, right? The g of x says, according to the information, the final value is 1 over x. So derivative is done. All we do is 2 times plug in the value of g of x from there. So 2 times the 1 over x minus 3. And finally, we are done. Our goal was to find this value. We started, and at the end, we find the value of f prime of g of x. Now our next goal is find that value. Once we can find that value, and we can plug that in, and we are done. It's a g function. So to start with, we must first start with what is g of x. G of x is 1 over x, which is 1 over x to the 1. We can just write it 1 over, instead of 1 over x to the 1, we can just write it x to the of negative 1. So x to the negative 1, it will help us to find the derivative. So what should be g prime? G prime of x should be the negative 1 times the x with negative 1 with a negative 1, right? So it's negative x with a negative x to the power of negative 2. We can't leave it like this. It's negative in front. It's going to be negative of 1 on the top. X to the negative 2 moves down. We are done. We figured out the final value of this. Okay, let me color code it. Sorry about that color. Let's just color code it with this one. All we do is we got the value of g prime of x. We got the value of f prime of g of x. We just put the value over here. First, copy that value. 2 times 1 over x minus 3. G prime of just the x is negative 1 over square root of, 1 over x squared. All done. After it's all done, it's just we have to simplify. Now it's 2 This one we won't simplify. It's a 2 times negative of 1 over x squared. So this negative comes in front, 2 goes on top. Basically, we are just multiplying these two parts and leave it as a factor. So it's 2 times the last value is negative, 2 on the top, x squared at the bottom. Multiply it by this value and just leave it like this. That's our final answer. Composite derivatives of the composite function is done. We will use this Leibniz notation, which is dy dx is dy over du, du over dx. What it means is, when we have a function like this, we explain it with the example. Y equals 2a squared minus 5u plus 2. Basically, is y is the function of u. So we have to find the derivative of this with respect to u. We can't apply dy dx. Next example, if we have another notations like u equals x squared minus 1, it means u is a function of x. We have to find the derivative of u with respect to x. Question says, find dy dx when x equals to 2. It gives a symbol, it gives a signal that the final value is going to be a number. It's going to end up with x's, but x is 2. But we have another problem over here. Let's get prepared for that. U equals, and it's going to involve u's. U says I'm x squared minus 1, x says I'm 2. So it's best to find the value of u when x is 2. So u is x squared minus 1. So the numeric value should be 2 squared minus 1. And finally u is 4 minus 1, which is 3. Now let's proceed with the plan. Let's try to find the derivative of the y. The y value is 3 squared minus 5u plus 2. So it should be derivative of y with respect to u. dy du. So it should be 3 times 2 times u to the power of 2 minus 1 is just the u. Derivative of the next value is negative 5u is just negative 5. Just like the way derivative of derivative of 5x was x, is the same way derivative of 5u is just 5 with respect to u. And derivative of a constant is 0. We don't need to write the 0. Simplified is going to be 3 times 2, 6u minus 5. So that's the final value of dy du. Next is find derivative of u with respect to x. So it's du dx. It's too simple. It's 2 times x to the power 2 minus 1, 2x. That part is 0. Now we are ready to apply this notation. We are ready to find dy dx. So we will multiply dy dx as dy du times du dx. We got the values ready over here. So dy dx equals dy du times du dx. dy du is this value. We have just done it. Plug in this value, 6u minus 5. And du dx, we just got it there, is 2x. Write the 2x. We are expecting when x is 2, so we can easily plug in x is 2. It's not a problem. We need to plug in a value of u, and we got it there in the beginning. When x is 2, under the terms and condition, u was that value. So all we do is plug in the value of u and x, and we are done. 6 times u is 3, 6 times 3, minus the 5, 2 times x, it should be 2 times that 2. So the values are color coded, and it's a very simple math. 6 times 3 is 18. 18 times 5 is 13. And that value is 4. So 13 times 4, which is 52. That is our final answer. And this answer is in terms of number. I put this video on the end. If anyone needs a prerequisites to handle the composite function, given that f of x is root x, g of x is x squared minus 1, find the following value. So what should be f of g of 1? So first thing is, what is g of 1? G of 1 is, we use the g function. Gx is x squared minus 1. We just plug in 1, it should be 1 square minus 1. And 1 square minus 1 is 0. Next question, what should be f of g of 1? That was the main question. We got the value of g of 1. And to handle the f function says whatever I put instead of x, I should put it under the root. So f of 0 should be just root of 0. And the final answer is 0. And we are done. Next, another quick and fast example. What we take if we take the opposite? What should be g of f of 1? To find g of f of 1, first, what is f of 1? So write f of 1. We go to the f function. It says put me under the root. If it's x, it's root x. So if it's a 1, it's just root 1. Finally, the simplified version is 1. So what should be g of f of 1? It should be g of f of 1, which should be g of 1. And g of 1 should be, go to the g function, whatever we put in the x, it should be x square minus 1. So g of 1 is simply 1 square minus 1. So 1 square minus 1 is 0. Example 3, what should be f of g of x? To find f of g of x, we need the help of the f function, the green function. So f of x, whatever the position of x, it should be under the root. So f of x is, works like this. That was x, that was root of x. So if I put the value of g of x and the value of g of x, we just erase that part to highlight this value. So this red value, the red block value goes in f of g of x. It should be f of the final value. So f of x square minus 1 is root of x square minus 1. That's it. Next example. What about g of f of x? G of f of x, we need to find what is f of x. But we will do that later. First, we have to find the find the value of f of x. I think yes. So what we have to do is plug in the value of f of x. G of root of x. Once we go to the g function, anything we punch in over here, we have to write that value. So if it was a x square minus 1, whatever the value we put, we have to square the value, subtract 1. So got the information from f of x, plug that in, final value, root of x whole square minus 1, root of x and a square, the root and the square is gone, so finally it's going to be x minus 1. And this is just a quick and fast recap of the composite